is everybody doing? Thank you very much for showing up with me. I just wanted to be that guy to say, hey, everybody's talking about this new native, this serverless, this Knative thing that we use to harness and give ourselves serverless capabilities. And you're probably wondering, like, yeah, that's pretty cool. Serverless can be cool. Native is awesome. They're obviously two, not competing, but two differently focused technologies. But moreover, they're both interesting, okay? So I find them very interesting. I find native extremely interesting. I think that the days of Java being the bloated king of the world of memory land and the bloated king of resource hogging is over. Yay, long live Java. Java 21's a month old, awesome. So, with that, we can kind of take it and go, okay, well, Java is capable of doing some really cool, lightweight, super scalable applications and extremely integrated applications as well, as you'll learn later. So, this is a little surface level, a little bit deep. This is a little bit underneath the iceberg of serverless. And I know this is an advanced audience, so I'm going to take that with a grain of sugar and add some, some contrived nuances to our native and serverless builds that we're talking about here. So I've been on a journey, and I've been creating solutions for, the RSocket and the reactive and Webflux scenarios. And I've been making, taking all of the different patterns, message queues, key value stores, JDBC data stores, and various request focuses like, WebSocket or request response, and kind of chronicling these things in one big application called Demo Chat. And it's an application that I'd like you to follow at some point when you get a chance, because it really does demonstrate what a large, not even a large, but what a standard, I guess, application platform looks like from the ground up. In other words, when you have so many criteria like key value store, JDBC, row level entries, caching, and you have all sorts of concerns that involve data going in different ways and coming out another way, this makes it a really good, it makes it a good candidate for looking at, the server side, the serverless side of things. Not that the server side isn't a thing, because they are on servers after all. But what I want to look at is what the landscape will look like if I were to decompose everything and turn it into a serverless, or if it's even needed, and to kind of understand, well, why does one embark on a serverless, voyage, especially with serverless being what it is, more servers, do I need it? And I really hope to support your idea and understanding of where it's going to fit within your context, within your organization. So this is Tips on Serverless, and it's Spring focused. Now, I hope everything here is correct. We can see my screen, good. So this is just an intro. I'm going to skip that. I'm Mario Gray. I'm a developer advocate at VMware. I've been here from about 5 years now, maybe 6, thank God. And I'd like to talk to you about this world, this thing that we call serverless. It's really an optimization. And if you've ever heard of optimization being the root of evil, optimization is that. But however, optimization is also necessary towards mid-level, towards mid-cycle. You want to optimize. You don't want to, have to spend 50% more resources than you normally would. And that's where things like serverless come in. They help optimize costs and sometimes complexity. Sometimes they can drive up complexity because you have extra pieces, the Kafka server or your message queue. But in an organization, depending on your organization, this can make it less complex. This will definitely make it cheaper. It'll make it more easy to fashion additional EDAs, message-driven architectures. Event-driven architectures. So what is serverless? What is the start? What is the key points in serverless? First of all, how can I say this? There is FAS. So function as a service. So what we want to do is we want to execute just a little bit of code, a tiny bit of code, something like and if you can follow me here, I'm going to slide out of slideshow and I'm going to go into a Java code. But let's look at this right here. This is a piece of code that used to be a regular service, a regular response reply. Then I said, hey, actually, this should not be a response reply. This should just be a function. So if this can be a function, then that means I could plop it into a stream and have it receive messages and output whatever results they are. And so with this, we have the ability to do something like enriched messages. If you want to take a message from one side, say for instance a message queue or even an HTTP request, you want to transform the name, make it uppercase, and push it back out, you do that. In this case, we're just adding something to a database and saying, okay, this thing was added to the database. Here's your key. Because everything you add to a database gets a key, and a function for a database would be, hey, add this entity and give me the key of the entity that you just added to it. So that's something I would do here. In fact, it would work in imperative code the same as it would with reactive code. So we wouldn't have to really think about reactive code, especially if you're using the green thread, the virtual threads. But with reactive code, you also get the ability to talk to all of your channel adapters and all of your message adapters that you'll be using in the technology I'll talk about soon. Okay, so it's about turning everything into a function, right? Input, output. The second thing is we have our event-driven architecture. And with that, we're able to trigger and make scalability responses. We were able to say, okay, well, given a certain amount of events or given a certain event, we could spin up or spin down services. We can add resources at will. And probably Dashan's made this clear, but being able to scale from 0 and down to 0 are very important things that the event-driven architecture allows us to do on top of fast. Scaling is probably the biggest thing that I guess, benchmarks are all about scaling, right? Like you want to know how fast this thing goes. You want to know, can your organization support this thing? You want to know, does it cost more to scale, right? So scaling is that thing that basically gives us our performance metric. And the more, let's see, the easier we are able to engage a scaling scenario with our application, the better our application is. I would say the more robust our application is. As soon as I can say, hey, can I scale this to 0 or can I scale this from 0 to n? And if that question is yes, how many n or when do you want 0? Without any other further discussion, then that's great. That's hard to achieve, at least in a lot of shops. And I tell you right now that many people are still looking for that holy grail. How do I scale to 0? And it still remains elusive in some circles, believe it or not. I'm not pointing at Elixir people, but I might be pointing at Elixir people. In this case, we have Java, and we're able to basically take everything that we have, that I have, that I'm developing and researching on, and turn it into something that can be scaled to not even 0, just the underlying infrastructure, and that's it. I'd love to do that, and that's my journey. So that's why I'm talking about this today, because it really invites developer wheels to kind of go and say, hey, how can I solve this architecture that I have now, and how can I make use of an integration type of architecture? And you're probably wondering, why did he use that word integration? That's because at the end of everything, at the beginning of everything, really, we have the idea of integration. And what is better than integration than Spring Cloud Stream? Probably Spring integration itself, built on top of a cloud platform that lets us change adapters and configure input outputs for not just functions, but also batch jobs, time delayed queues, things that will get triggered. So Spring Cloud Stream lets us essentially, I would say, engage EDA at a more personal level. We begin to adopt EDAs with Spring Cloud Stream. And one of the reasons why is the lingua franca for streams are in fact messages. And these messages are essentially the thing that we are talking about in payload. For instance, the message here, the actual data here is a request. I have a request object and I have a message object on its output, right? So in coders parlance, I have a data type. I have 2 data types, input and output. I don't care where those data types come from. And I don't want to have to care. I want to develop the application and make the logic work as a developer. And so I shouldn't have to think about things like, do I need Kafka running? Or do I need RabbitMQ? Or do I have a message, pub sub or something like that? Do I have to worry about being able to access my message source? So with Spring Cloud Stream, we abstract that away. We take that those input-output bindings that they're called, and we say, well, they're generic. Okay, you can put Kafka there, you can configure Kafka, you can configure RabbitMQ, and it's going to work the same. The operators on the other end will probably wonder, well, can I, replay things, right? Can I store this for a while? Is it ephemeral or is it durable? Those are questions that the operator is going to ask about what platform they're going to use to store and shuffle data around. And as usual, I won't say the name, but there is a certain Apache project that is well known for being a distributed queue service, as it were, or a distributed stream service, as it were. That is, everything that you send to a topic is not only saved, but you can rewind. You can pick a place of a million items and say, hey, I need to play events from a certain point in time, and kind of have the world of your application state become revitalized with that data. So in other words, it's a way of saying, hey, I want all of my state to be somewhere. You can change, if you have a message system, all of your messages can be replayed, and whatever state you arrived at in real time at some point can then just be deduced based off of the events. So that's what I like about Spring Cloud Stream, the ability to engage EDAs and the ability to abstract away the message process, the message sending and reception pieces. That's a very important part. They're durable, and they don't, if something fails, I can replay it. So that's a very important thing. Don't worry about that. That was just another slide. Now, because Spring Cloud Stream is such a project that is worth mentioning, at least for a very long time, you should probably are using Spring Cloud Streams in various places. You probably also know about Spring Cloud Function, which is the fast variant of the Spring Cloud Stream. In other words, you're able to deploy individual functions with wrapper code that do the same thing as a stream does, only this is just for fast. This is going to give you a binary, and it's going to give you a container that runs a single function and then disappears. So these are ephemeral. These might run for a couple of minutes. They might take several requests, but then they disappear out over time. Whereas with streams, you usually have processing in there. These things are long-lived. Maybe they last hours. Who knows? Functions, they should last like, a very short amount of time, right? So Spring Cloud Function excels at that. As you can see, it does support all of the Spring, runtime targets, things like auto configuration, dependency injection, and metrics. Of course, it's a Spring project. Why do I need to even mention that? Hello. So this stuff is going to make it easier to get into the function or FAAS realm. From that, I would say, let's say we have SCS, we have Spring Cloud Function. I think we have one more horse to deal with, one more big horse, because I believe that SCS and SCF, that is Spring Cloud Stream and Function, are two big ideas within the whole entire FAST community. Oh yeah, that's the other one. So you probably compiled stuff before, and you said, hey, this might take a very long time. Why does my stream need to wait 1.7? Why does it need to take 2 seconds to start? Or why does it need to take 20 seconds to start? And that's because, well, typically the JVM has to start and do all of its stuff. Reminding myself now that the JVM is not the scourge, but rather the friend. But traditionally that might take a long time, and you probably want to reduce that time. And the Spring team has done everything. For Dave Zayer, I watched him for months just do things that make Spring faster and faster and faster. And he really went from a multi-second down to just a couple of 1 or 2 seconds before native was even introduced. So the optimizations on the Spring side have come first, and then the native parts come. and they really drive down the execution start times and the amount of time it takes to initialize your application server. So thanks to the Spring team, we have epic load times that challenge even the Node.js or Elixir people, or I can say the Python, but those guys aren't our enemy. I'm just kidding, they're not. But we're able to take care of those load times, and when you're dealing with function as a service, you don't want to get a build and say like, well, 60% of the time was loading. That doesn't make sense. So native is here. Epic load times are gone. Native to the rescue. And as you've heard earlier from Deshaun, he's able to just build native images even on older Spring Boot applications by just upgrading or doing the right thing. If you have already, good for you. Use the new Spring Boot 3.1 and wait for 3.2 to come out and use that too if you can. But we really want you to use that new stuff because you can get the biggest benefits. You're not gonna you can't go anywhere if you don't upgrade. So I can't go anywhere if I don't upgrade. And I've been through that upgrade cycle a few times, and it's never that painful. It's actually pretty easy. The hardest thing is this Javax namespace changing. Anywho, back to this native images. You heard Deshaun talk about it. You know how it works. Blazing fast load times, very small memory footprint, excellent for fast, excellent for basically any use. I mean, honestly, you wouldn't want to not use it anywhere. But it makes a lot more sense when you're dealing with things that are going to need to load very quickly. And that's what this does. So using native is fun. I won't show you an example of native right now. I think Deshaun has done that already, but a native build is basically just a switch on your Gradle or Maven build. And okay, I will show you something. I promised no code, guys. I promised no code, but you know what? There is going to be a little bit of code because if I can't have a good talk about native serverless without talking about the actual build process. Something that you probably are using Tekton for, or maybe you're using Knative build for. In my resources, I've used neither of those so far. Tekton, I'm going to need to integrate with Tekton, but currently I'm just using standard build packs and build services, and really just going through the steps of outlining my application build process. Now, the application build process shouldn't be too complicated for most people, but you do end up with applications that have lots of parameters. Okay, and what happens when you have lots of parameters with the native? It has to be built in. It has to be baked in at runtime. Do I have that slide? Yes, I do have that slide. Okay, so here's a couple of things about native. When you're going to do native, specifically for any situation, understand these three things. We probably heard this already. I didn't hear it already, so I'm going to talk about it because I hope they're interesting to you. But I do think that I have to remind myself every now and then that, oh yeah, of course, that's why it doesn't work. For instance, your class path is fixed. You can't just dynamically pull in new classes. I mean, you're probably not doing that, but I've probably done that somewhere as a junior dev. Maybe, just because, who doesn't like pulling in JNI code? Who doesn't like pulling in Perl code to run? No, yeah, okay, we don't do that. But really, the static bean definition. Okay, so basically it's not static, but it's the fact that your entire class path, your entire Spring Boot application context has to be cemented at build time. So what that means is rather than your application starting up, discovering all the beans, initializing them, doing any properties and any sort of conditionals at runtime, that can't happen anymore because those things need to be kind of baked in into actual machine code now. So we don't want to do any translation in runtime either, because that just, you're going to need a few hundred more megabytes of runtime, and you're going to need more time to do all of that extra stuff. So get rid of all that baggage that you won't need. Make your application as streamlined as possible by not having any changing properties at runtime, for instance. So when you have to change properties like your JDBC username, password, you have to have a separate scenario for that. You can't just push the property to there and allow it to load. Now, I'm not 100% going to say that you can't change databases or you can't change database drivers, but it can't be something that needs to be reloaded at runtime. So if your class driver, if the driver class changes, that's not going to be available. You cannot have dynamic property files, which is of course understandable. Not many people do have dynamic property files. You might not have something that's loaded automatically at runtime, for instance, like by console. You might, your application sees console, goes, hey, give me your config, loads the config, and then starts up. You might have something like a profile, for instance, and if you're executing like a program like this, I have so many options. Let me just look at the options. So what we're going to do is just look at a simple, so this will work, I guess. Let's see, cat, let's do that, and say pb copy. Okay, and then let's just create a quick new script here. New script that is, you know what? It's just a bunch of options, you guys. I mean, look at these options. So knowing that you're going to eventually have to, not have to, but you will, and you have, and you probably are not scared of this. I'm scared of this. I as a developer, selecting the options for the ultimate executable of my application is one of those things that keeps me up at night, because so much can go wrong with just the wrong option. So if you've used Spring Cloud Dataflow, for instance, you'll notice that there are a lot of options that go into each one of the components that you deploy. And those options change things like from the message queue that you're using to the name of the queue, to the data type that you're going to be trading, sending and receiving, all that stuff. It gets configured all up front. And likewise with native, you have to configure this stuff up front at compile time using Java tool options. Was what I do. This is my this is how I do it. This is how Mario does it. I use Java tool options at build time. And I tell Maven, okay, build me a container, or just build me a jar file that has all of these options that I've selected somewhere, maybe in a, I don't know. Did I put this in Kubernetes yet? I know we have these in Kubernetes as well. Right. So the essential thing is get all your options, round them up all at once. Get everybody ready to get deployed, so that your application will work in native. Because without that, then, if I didn't select this, for instance, and I selected it at runtime when I executed the native binary, it wouldn't work. I wouldn't have a core index, and that would suck, because then I wouldn't be able to search for things. And application developers like searching for things too. I guess we do have some sort of deployment going on here. Did we put all of our options in here yet? Let's see. No, we haven't put all of our options in here yet. Not just yet. So therefore, they are baked into the jar file, or they are baked into the native binary file, which is perfect, because I don't want to have to tell Kubernetes, here's the environment, especially when it's native, and that just won't work, because you can't pass stuff to it. So moving on, we know that we need to have our world baked into the binary as we're building it. You can interact with AOT for things that are not currently seen by the class path, or things that are not obviously exposed to the class path. You will be able to generate AOT hints that say, here's how to get to a particular class, or here's how my data file, here's how that data class that I have, here's the source to it, here's the place that it exists, so that you can send it to Jackson, so that Jackson can interpret it and turn it into a YAML or something like that. I'm just kidding. It wouldn't be a YAML. It would have to definitely be a JSON file, I hope, but not XML. Excuse me. So is that the end of that, of the native as a closed world scenario? Yeah, and it doesn't, I know the words native as a closed world scenario sounds terrible. It sounds like, oh my God, you can't do anything with it. As a developer, I guess I might be a little bit constraining on this, like saying, hey, you can't do anything, but I'm just kind of outlining what is going on that will cause you to have a hiccup. Things that I've run into, for instance, that 4-hour scenario where you thought you had a bug, but it actually wasn't a bug. It was just you had a profile type of deal. So I'm just talking about this because of that. Now you read the manuals, and all of the stuff is in the manuals. If you were to read it all, serially, you would get there. But hopefully, what I'm doing is I'm giving you some clip notes and maybe something even more insightful. Here's your build. Here's a deployment. This is this is the Knative deploy. This is what you probably see in most of your Knative deployment scenarios. This is a typical workflow. So we're just talking about eventing. We're talking about, like, how does your Knative service even get seen? It's all by this event service. It's a thing that says, hey, if I receive an event of type A, and type A's are registered to a service called membership, whereas A says for any A, give me a membership for all of A, then that's what happens. You say, hey, I'm going to pass a number to a membership service, and that number comes out with a whole lot of other numbers, which are keys to the things that A is a membership of, right? So that's your input and output. So your eventing, it has to happen somewhere. So that eventing happens in a component. Usually, I think it would happen as a trigger, maybe even it could be an ingress, I believe. I'm not gonna make things up, so I'm gonna move on. But essentially, your Knative eventing has to be something like a web server or just a message queue, and it has to be able to notify your service that here's something that you need to process, and start the service up, process it, take the output, put it somewhere, whether it's back to the user or in a queue somewhere, wherever that destination route's set up to. Essentially, it's just EDA, okay? It's EDA where you have somebody listening for the actual messages, saying, hey, if I hear a message and this guy's not around, I'm going to start him up. That's what Knative, I believe, really is. Okay, so, this is the deployment scenario that I'm looking down the barrel of. And I want my deployments, I want them to work, the first time, maybe the third time around. And I don't want to have to tinker too much with the source code of Knative to figure out what I did wrong, for instance, or figure out the source code of Reactive to figure out what I did wrong there. So what happens is we need to test. So when you're doing native programming, obviously when you're doing native, not just native, but when you're doing serverless or any sort of programming for that matter, I like to bring up testing. Because, well, I mean, who doesn't test their code? Do not raise your hands because I can't see you anyway. But if you did raise your hands, I just want to let you know that Elixir is still a decent framework. But Bob Martin, you probably heard him on Twitter or X, whatever we call it today, lament about, testing code and how everything should be tested. And he seems to be a staunch defender of the TDD cycle. And we know that if you read his X's, God, I can't say that right. If you read his tweets, you find that people fight back and no, I don't want to do this. I do not want to believe that this is the world that I grew up in. I do not need to write that many tests for my few components, right? But what do I have to say about that? Is TDD is a way of life. It's kind of a cult, if you want to believe it that way. So if you want to drink from the waters of TDD, you can't go wrong on it. You can spend more time than you would ordinarily on testing, because if you don't write tests, then you're going to be spending more time on tests. But it does allow you to understand more of your application code up front without writing production code. And that's one of the things that I found with TDD. And Spring supports TDD in a great way. Obviously, you know this if you've developed for any length of time. Things like WebFlux can be tested very simply by, let's see what we have here. You just use WebFlux test. Aha. So if you're doing WebFlux, for instance, you just use WebFlux test and you start writing tests for, a server entry, a server endpoint that you want to, make sure that it returns a certain type of element, right? So you just write the test first, and then break the test, because once you run the test first, it won't work. So then you go to production, you write the production for it, you test it again. Does it work? Good. Go to the next test. So the loop is pretty tight there. Also, exactly what you're going to be coding for as well. And I think that's kind of an important thing. Parallel to that is also this whole REST document thing that I've kind of gone crazy hog wild on. I know this has nothing to do with FAS, but if you're doing REST, then REST documentation is really awesome. It allows you to just start pushing out actual REST docs from your endpoints, from your tests. Your tests drive the output of REST documentation, which is great because you don't need to rely on annotations. You don't need to rely on another person, a writer, or whoever it is, to get anything wrong. You don't have to maintain that extra bit of cruft on your production code. It's your test code that drives it, which is great. This also drives the DSLs for the contract. So now your contracts are written as well. So if you write a client for this guy, then there's a contract already available to verify the actual server against, which I think is lovely. And I hope you find that lovely too. Now, I'm going to, I'm sorry, I can't hear. There we go. Okay, so that's testing right there. That's how I test is just, I test first, I write code second, because it tends to work in my head. It goes straight up here first. So that's step one. And step two, step one, don't write any production until you pass that failing unit test, or make that thing pass. Don't write any more unit tests than sufficient. I usually skip number two. For TDD, skipping number two is okay, right? Because like I already know what I want, so I start writing the whole thing. And if it's too much, and if I have to get rid of something, maybe I'm doing something wrong. But writing just a little bit of it means that I have to think about what I don't want to write next, and I think that's a cognitive thing for me. So you mix and match your 1, 2, and 3 and see what you get better of. Okay, but basically, just don't write too much. That's all. It just says don't go overboard, and maybe we have gone overboard. Maybe as a junior developer, I've gone overboard. I've written gigantic tests that emit that are just what production looked like in test, and then I just ported that to production, which is wrong. Like I should never do that. And so I stopped doing that because I realized that number two got me in that place where I just wrote way too much test. All right, so then number three is, hey, just don't write any more production code than you already need to make that one test pass, and that's it. So essentially, every feature that you write a test for, just write that much code, and that's it. Hello. Hello, Bob Martin, and number 1, 2, and 3 for TDD. Now, if you do TDD, good for you. If you don't, not so bad for you, but I do hope you test. And so I love testing. This isn't really the conclusion because we don't conclude with just testing. We have a few other things to talk about, like Spring Cloud config server. For instance, when you're doing fast and you want configuration to be there, you want to be able to know where your servers are discoverable, and you want to be able to register your servers as they appear and disappear. You want something like Consul, right? You ever use Consul HashiCorp? You can use Consul, or you can use Spring Cloud Discovery Server. Now, one of the things that I do is I like Consul. It's a habit of using Consul. If somebody wants to lambaste me about using Consul instead of Spring Cloud Discovery Server, go ahead. We'll have that talk. I'm looking at you, Deshaun and Spencer, probably going, yeah, you got to use that config server. But every now and then I like to do some, exploration outside of the Spring realm, and I'm using Consul now, and I find that Consul is actually pretty cool. Consul is, it's got Raft. It knows how to talk to all of the nodes in the matrix. Basically, you have multiple Consul servers. They all have the same config. It's the CRDTs, the conflict-free replicated data types that allow us to have configs across the world and not really skip a beat, right? And the fact that Spring supports Consul so well, I mean, you can only use it. You have something called the Consul client. You can talk straight to Consul with the Consul client. Consul discovery properties are just the things that you use to tell, like, hey, how do I talk to Consul? What service am I going to be looking for? What are my tags? Stuff like that. You can program that all up in your source code. You don't really have to do much to get Consul to talk to your Spring application. Granted, I probably did talk about, I probably did talk about deployment options. And of course, Consul does have a number of deployment options. We don't need to talk about that here because this isn't about Consul. This is about using discovery servers and directory servers for your functions, because they allow your functions to essentially know where the other functions are, or know what something is if your function needs to call out. And hopefully your functions don't call out, but I know that does happen. And your functions aren't going to be the only thing that call out, by the way. If you're using Knative, you don't need to use functions. You don't have to use functions on Knative. You can put batch jobs on there too. You could run workloads, okay? So your workloads are going to need discovery as well. Anything that you need that talks to something that's not local, because functions really don't need to talk to anything that's outside usually, but your jobs, your long-running tasks do, and they need to maybe speak to a JDBC server. So that's why you want discovery, and your discovery is going to allow you to essentially prop up a a map of your data matrix, of your server matrix. And if you like that word, server matrix, it just rings server matrix, because we're talking about serverless. So like, what would a server matrix be in a serverless environment? I don't know. Matrix, I don't know. Somebody who knows math, please tell me. Okay. All right. So moving on. Besides the obvious, let's see. You know what? No, we want to do one more. We want to talk about Spring Security, because one of the other tips is you guys got to use Spring Security. Everybody has to use Spring Security if possible. Spring Security is very easy to use. I just learned this. Josh Long was talking to me about the authorization server the other day, and I said, yeah, I don't know how to use that thing. That thing is like, it's Greek, but it's not. It's actually super duper, ultimately, holy moly, easy. Just plug in a JDBC server for your authorization server, for instance, and it works. Holy moly, I did not know it was this easy. So Spring Security provides the authorization server. That's for OAuth 2, JWK, JWT type stuff. But for the framework itself, you want to do something like, I want to authorize a role, right? I want to be able to say, hey, this particular session or this particular object can't be processed because it doesn't have the privileges to emit an output, right? So you get stuff like that. You get services that say things like, oh gosh, what are these guys doing? Outside or in here? No? Okay. Well, all right. That's just a bunch of code. That's just a bunch of secure code. I wouldn't look at that. Basically, the main parts of Spring Security is to use something like pre-authorize. So you would say something like, hey, pre-authorize, and then say like has role admin or something like that, right? So you would do that. You would say, hey, I can pre-authorize my functions to do the same thing. I want to be able to say, hey, this guy passed in a token, and that token resolves to a user, and that user, this might be a JWT, for instance. You unwrap the JWT, you find the user ID, and you do a lookup and say, hey, that user doesn't have access. That's what pre-authorize will help you do, is basically access the user privileges or the execution rights of whatever is trying to produce output. Okay, so then what we have is the conclusion, or a conclusion. I want to not say the conclusion, because this is a ongoing process where I developed the strength to talk native, and not just native, but function as a service, native function as a service, which are very compelling. I need maybe 2 servers, and I don't have to worry about anything else. I'm done, right? Give me a Kafka server, give me a JDBC server, and everything. All right. So conclusion is, who's heard of this serverless is not really just servers. I mean, it's just servers underneath. It's kind of the Scooby-Doo thing where you have, one of the Scooby-Doo kids yanking the shirt from the monster, the evil, old rich man. And it's just, another version of him, or it's like LeBron James or something like that. Serverless is not just servers. It's really just infrastructure. You just don't need to think about it. A developer just abstracts away the infrastructure. You probably heard this before. I'm probably just repeating it, but I'm saying it again because it can't come more over the head easy, right? It's supposed to make it easy to deploy, given you have just a function. I mean, those things are just, you're brain dead, easy to deploy. You just take a function, you build it, and you say, hey, can you put this function out? And, here's the condition to make it run. I want it to execute on Webflux at /all or something, whatever. We'll get there. We'll get to a hello world at some point where we just start developing Knative stuff to really just kick the tires of native programming, what it's all about. But for now, we're talking about it. We're really like researching this stuff here. We have the time sensitivities. Oh, actually, I'm sorry. We have a plethora of options. We have, the do-it-yourself Knative. You just launch. You go to the Knative. You download the app. You run the setup, the configuration script, and you have a Knative deployment right there, and you can start just doing stuff. It's really simple. You just run a script. Your Kubernetes is now imbued with Knative, and when you're done, you can just rip it all back out. It's really cool. You have AWS Lambda, Google, Azure. You have a lot of different native platforms that you need to think about. So if you're using a hybrid environment, then you would have to think about what environment are you using for maybe your Lambda or your Google function. Google Lambda is probably the most easily accessible on the cloud. I've used it before, and I think it's pretty darn just super. Look at Dan Vega's Tanzu write up on it, and it shows you it's pretty darn easy. It's time sensitive. Jobs have to complete very quickly. So these are functions. These are things that shouldn't live very long. They're not batch jobs. So when you're deploying another function under this FAAS, you need to make sure that that is like part of the SLA. I guess like that thing should like come up and then come right back down. And this is my case. This is the case where serverless really kind of goes, I don't know. I'm not really sure yet. It's the part where you start evaluating your legacy cases. And it's the part where you start going, well, do I have legacy cases that I need to turn into serverless? And you start asking yourself those questions. Your architects go, okay, well, what can be serverless right now? And they pick a couple of candidates and they say, well, okay, we have a couple of projects that we're going to make. Hey, these are, serverlessable. They don't need to exactly be like long-running services. And things like, when you're looking at your code, you're probably going to think, well, I need to be able to select something that I can now turn into a serverless function. What would I turn into a serverless function? Let's see. How about messaging? How about we just like we do messaging things as a serverless function, right? We showed you the chat streams, which is I have a message type, and that message goes through a function, and that function turns that message request into an actual message, and it puts that out back into the topic. Maybe that's something that we can start first with, right? So as I send my messages, I don't need to send it to the R socket or the WebFlux endpoint or the WebSocket. I can send it to another place that's actually backed by FAAS. And then I can kind of do some performance analysis on my own and say, okay, well, I like the way this works better, or actually I like it as a server, and does it cost more? Do you expect the type of traffic? Are you doing multi-tenancy? If you're doing multi-tenancy, it probably makes more sense to go with a long-running server. It might make sense not to go with a long-running server if you're multi-tenancy on the FAAS boundary. So those are things to think about, and honestly, they're things that keep me up at night and keep me from programming so much. Like, did I really code that well? No. Or did I really make that work without the function? Yeah. Anyway, all right. Okay, so I'm gonna leave this by saying one of the things that you're gonna need to do to learn about this stuff is to learn about this stuff using Spring Academy. And honestly, Spring Academy is probably the one place that you didn't think about talking about any point in time during the day, but I think that it's something that it's worth talking about since we're talking about kind of a new paradigm for Java time, for the new time of Java, the whole native, the whole virtual threads, the syntax, the language syntax, Spring Boot 3.2 coming out soon, reactive becoming maybe a programming paradigm that everybody uses, or maybe it's on the wane, who knows? How do I learn more about this stuff? Spring Academy. How do I learn about Spring Cloud config servers? Spring Academy. How about Spring Cloud Stream? Guess. Yeah, you got it. Okay, so there is a free trial of Spring Academy. I believe your sales rep can actually point you to a discount. I hope. Definitely ask your local VMware Tanzu sales rep or handler, whoever you call them, Jim, about this, because you can get extra discounts for learning Spring stuff, and you can, with the non-free tier, you get certification, you get the hands-on lab, you get like a much better learning experience that sticks information directly into your cranium, and we love that. We love memorizing things and being able to demonstrate that. All right, so given that, what else? Did I have any question? I heard a question, but I didn't recognize the answer to that question. So if I might, I'm going to relinquish the mic to our dear, amazing, and obviously hardworking MCs and Deshaun and Ryan and you guys. Native is amazing, but it's kind of the beginning of the story a little. It's kind of still like, hey, we have this whole native thing where we have all these workloads, we're translating, from point A to point B. We're not sure if we're going to go completely, native Java yet, and we're not even sure if that certifies us for doing things like FAAS on Java. What do you think? Is that something that most organizations have already gone and said, yeah, we're done. We don't need native until we do native. We don't need fast until we have native. Or are they like, no, we're going to do native. We're going to do fast anyway. Like we need it. Like there's two camps there. There's I gotta wait. This thing has to be faster, or I'm gonna end up using Elixir. Um, and in most cases, you don't want to end up doing that. What you do want to do is you want to refactor. You want to look at your code. You want to go from where in the world? Let's see, persistent store. So we're in a world who doesn't have an interface that looks like this? This is a typical repository, right? Yeah. Oh no, I'm not even sharing my screen anymore. Whatever. Take your average server. Add, remove, delete, find, and then turn those into functions. Try it. See if you like it. That's all I got. Thank you. Also, thanks a lot for being here.